My name is Rick and I wanted to share how for 15 years I've managed to keep this oven going, and finally and very recently giving in and changing the control board to the latest version. In the notes below you'll find a link to all the slides in this video, and so I may not dwell on some of these slides for very long, but this is a list, for example, of the various problems encountered, and I'll be describing how I fixed them in more detail. The actual problems encountered were, first of all, crosstalk, as multiplex signals run down a ribbon cable that links between the keyboard and the circuit board. And when I say circuit board here, there are actually two that are joined together. On the main power board, failing solder joints, which are the result of the board overheating, breaking link wires between the boards, which is also due to overheating, failing relays, again due to overheating, and short circuits due to what's called dendrites, which are kind of little whiskers that migrate between circuit traces and can cause short circuits. I'll deal with crosstalk first because it's often one of the first problems that manifests itself on this oven, and it's easiest to fix. It's as simple as opening up the front panel and getting access to the ribbon cable that runs between the keyboard and the control boards. And all you have to do is cut a strip of paper about 9.5 by 2 and put it between the separated sections of that ribbon cable. I should add here that before doing any work internal to this oven, you should switch off the power at the circuit breaker box, because there's 230 volts here and it's absolutely lethal. Again, this slide, like all the others, will be in the document linked to in the notes below, so for those interested, here's a little more explanation of why the crosstalk is occurring and why the paper strip helps mitigate it. I'm not going to read this slide either, but dendrites are these whiskers that can grow between the traces and solder joints on a circuit board and cause short circuits. And you should look for them with a magnifying glass if there's no other obvious reason as to why the oven isn't working. And you may find some of these on the power board, and you can clean them off with alcohol and some sort of Q-tip or old toothbrush. Failing solder joints are by far the cause of most problems in this oven, and that's because the oven that gets to be used most, because it's most convenient, is the top oven, and the circuit boards are located directly above that. And you can see from this graph, and I've given a credit to where I got it from on the internet, that solder hardness decreases drastically with temperature. The only thing that's changed on this graph is that I've added a Fahrenheit scale, and you'll see that I've marked in red where 210 degrees F is. That's the point where the cooling fan comes on, and it's pretty high, so the hardness of the solder has decreased by quite a lot by the time that fan comes on. Most people only hear it when the oven is in a cleaning cycle. These solder joints can also fail more when they're under tension, and there's tension in the little wires that join the two circuit boards together. I believe they are copper, although they seem rather springy. They're certainly not magnetic. And I'm not a metallurgist, but I believe although copper will soften if heated and suddenly cooled, it will actually harden if heated and slowly cooled, particularly if that's done repeatedly, and of course that is the case in this oven. So there's tension on those little wires. Also, all the relays have a slight movement internally when they operate, and that after a time, and I've seen this not just on ovens but in furnaces and in automotive things or in a microwave, those relay contacts will start to cause stress on the solder joints in elevated temperature conditions, and they'll start to fail. So that's the main reason why we get most of the problems on these ovens. What we've done here is release the latches on the plastic case and folded out the power board so you can see the bottom of it. And I've put an arrow pointing to all the large pads. That's because that's where the relays are mounted. Now you can get a relay failure, and I have had one of those and had to change it, but those relays are now extraordinarily hard to get hold of. But what normally happens is that the solder joints become bad because of little movements within the relays, causing those joints over time to weaken. Now you can identify a particular relay because there isn't one relay that's an overall master relay that stops everything functioning. You'll probably find that maybe just one thing like broil won't work anymore, and you can target that pad if you like, because on the other side of the board the relays are marked as to their function, so you can look for the broil one, go underneath and see if the solder joints are good or bad. However, as an ounce of prevention, I would recommend going over all those solder connections on the back of the board there and reflowing them. That's to say, putting a soldering iron on them, and if necessary adding a little bit more solder to them just so they are renewed. The other common solder failure here is on those link wires, which, as I've said before, are under tension. And unfortunately, when you have to get to the bottom of this board, you actually have to move them. And I've heard them go ping, ping, ping like piano wires, and they fail on you. You try and repair them, and you may see some hand-fisted repairs here where I've pointed those arrows. When you repair them, you think you've got them all, and you fold the boards back together again to reinstall it, and you may hear more pings, and it's really frustrating. If you want, you can, just as I did with the relays, reflow those solder connections. Unfortunately, there are 60 of them on each side, so you've got 120 to do, but again, an ounce of prevention. At one point, this oven was failing time after time, maybe every couple of months or so, and the one thing I did that spaced out the problems at least and turned those months into years before I got other problems was to change the thermostat so that the fan came on and cooled that cavity above the top oven in which the circuit boards are located, and kept the temperature down, and therefore kept the solder joints from going too soft. Now this is a picture of my thermostat, and it will look different from yours because I have changed it. It's not the original one, and the one I got, I could not get one with the smaller contact, and so instead of using the 3/16 contact, I had to use 1/4 inch connections, and those connectors had to be changed on the cables or the wires coming to the thermostat. That thermostat you'll see in the cavity right above the oven when you remove the panel at the front. The reason to change the thermostat isn't that the old one is bad, it's just that it's set to too high a temperature. So what we want to do is get another one that will come on at a lower temperature. This picture shows the original thermostat, and its specification is shown on the left. You'll see that it closes at 210 F and switches the fan on, and won't open again until the temperature falls by 49 degrees Fahrenheit to 161 degrees Fahrenheit. It mounts so that the sensor part, that round bit in the middle, is touching the floor of the upper cavity, which is obviously connected closely, perhaps with some insulation, to the roof of the upper oven. Other than that, the things to note are that it is automatic reset. Some of these thermostats have a button and you have to reset them manually. This one must automatically reset. So if the temperature goes up to 210, it'll close, the fan will start to work. When the temperature falls in that cavity by 49, it will go off. But if the temperature should rise again to 210, it will automatically close again. Now on the right, I've put what to look for. I actually have a 160 degree closing thermostat in mind, but there is some flexibility on that. So first of all, look for one that will work at 120 volts AC. That's a must. It must be a normally open one. Normally open means that at ambient temperatures around 20 degrees room temperature, the contacts are open and they only close at abnormal temperatures, i.e. in this case it was 161, but we'll go for something lower. So we want to have some contacts that close anywhere between around 140, say, and 180. Automatic reset, as I said, is absolutely necessary, and that sensor end must install so it touches the mounting surface. There is a wish list where you can have maybe some variation and do a little modification. If you can get 3/16 contacts, all the better. That's what's on the oven right now. But you can cut those off and change them for 1/4-inch contacts. They're very common, the ones that are used in automobiles. And if you don't want to mess with hole centers, I've given the hole centers here of the original thermostat, and you can work around that. At the bottom, I've put some possible North American sources of thermostats. These are the main places you can get electronic components in the US. I don't know when you'll be watching this video, but at the time I'm making it, I did an internet search and found these two sources. I say two sources because, in fact, although one comes from eBay, it's actually the same source on the right as it is on the left, except the prices are very different. I'm not sure why. Maybe the company, when it sells directly, only sells to industry, and you have to pay industry prices, and if you're buying from eBay, then you're paying public prices, which are apparently much higher. This thermostat switches on at 140 degrees, and the hysteresis, that's the difference between the on and the off temperatures of the thermostat, also known as the backlash, is only 20 degrees. That tends to be the case. The lower the on and or off temperatures of a thermostat, the lower the hysteresis. This means that the thermostat will switch the fan on at a much lower temperature, which of course you want to keep the solder connections on the circuit boards cool, but it may switch off and then cycle on again as it cools the upper cavity, but then when heat trapped in the oven below tends to warm it up again, it'll come on again. You might find that cycling annoying, but it's not nearly as annoying as the oven constantly going wrong. This, after 15 years of repairing the oven, was the last straw. What happened was that a bad connection did occur on one of the relays, and it blew a hole in the board, burned the contact mostly away, and this eruption, like a volcano, also with a crater of course, blew matter, soot, debris across a lot of the board, and I had to clean it all up. But it really never worked properly again. I did get a connection for a bit, but it was such a bad connection, it just kept failing. And in the end I had to give up and say, okay, I'm buying a new circuit board. My next step then was to go to the GE parts website, and this is what I found. The part is no longer available. I also found some comments on there, and it appears that GE at the time, GE Appliance, only keeps parts for 7 years, or guarantees to keep parts for 7 years. So you can buy a $2,000, $3,000 appliance from them, and it may only be good for 7 years if something goes wrong. By the way, GE Appliance has been bought by a Chinese company, and I have no idea what their current policy is. I was fortunate to find this on the website of a company called Day Parts, which gives an alternative circuit board to the original. But unfortunately, Day Parts themselves did not have it available. I did, however, find the board on eBay, and if this seller still has some, if you're looking for one, all I can say is that it came quickly, it was well packed, and it absolutely worked. This one does have the relay for operating the lower convection oven. I didn't need that, but I guess it's a spare. If I ever should have another relay fail, I could probably swap it out for the one that I'm not using for the lower convection. This shows my old board. I do recommend you take photos and that you label every wire to note where it went. And you don't see the labels here. I did do it, and you will see them in a later picture. But it does help to know which wire goes where when you're putting the new board in. This shows the wire connections for the original board, and be careful, these are the colors on my board of each wire, and I can tell you from experience that manufacturing companies will not stop production if they run out of a certain color wire. They'll just use a different one. So it could be that on your board that the wires are different colors, and if they are, make good note of it, please. Maybe print this out and just mark it up with your colors instead. This is a view of the new board, and the most obvious difference you'll see is that some of the connections come directly into the relays. This should help prevent some of the problems we have with the old board. The broil relay particularly, which is the highest current one, has the power coming directly into it on the L1 contact for the upper oven, or for the L2, the other phase of the power coming into the lower oven. So those broil relays get their power directly rather than going into a contact, going through a trace and then going through the bottom of the relay. However, the problem still exists that that relay then takes current from the bottom of it into, first of all, the bake relay, daisy chains into that, and from the bake relay into the convection relay. That's the same for both upper and lower. The other thing you're going to notice soon is that you can't get the film ribbon cable into the new connector, and that's because there are a couple of keys at each end, and so we have to modify the cable in order to get it to push into that connector. There are a couple of rectangular holes in the film, and you're going to have to make those into a slot, but unfortunately it's difficult to do without damaging or cutting the traces that are existing. You can probably see the marks where the contact on the female connector on the board have rubbed on this cable, and so that's the contact area, and so long as you don't touch that, you should be fine. Just cut a couple of slots, take a lot of care, and you should be okay. Once you know you can get that ribbon cable in, you can connect everything else up. The multi-pin connectors should go in just as they did before. Be careful, however, it is possible, particularly for the one on the side that looks after the fans, you can put that in like a pin over if you're not careful, and you need to make sure that all those pins are connected. There's not one hanging off the end. Again, the colors are the colors on my oven and may be different from yours, so make sure you cross-reference those with what you had before. Here's my new board all wired up. You can see the labels I'd put on the cables beforehand so that I could more easily identify them. Everything works, and I am still going to put that paper between the films of the ribbon cable because crosstalk will just occur again with this board as it did with the other. I'm still going to keep my low temperature thermostat. Although this board should be more reliable, it's better designed from the thermal point of view, it's still going to get hot in there, and I think I want to prevent problems on this new board if I can, so that will stay there. Thanks for listening. I hope this has helped you, and good luck.